Hello, and welcome to Module 6 in Data Science Languages. In this module, we'll be talking about data transformations. So moving in, again, our agenda, we'll be going over Module 6, talking about Python, R, and the reading associated with each, and then also deliverable number 6. So Module 6, again, data transformation. So you may be asking, well, what is a data transformation? Generally speaking, it's whenever we do things like feature engineering is the fancy word. And the idea is that you take data that's in one place, in one shape, and you potentially change that shape to something that's more desirable, more conducive for an analysis and enabling you to do the work that is necessary on that data. So we generally do that as part of the processing to make sure that the data is in a certain kind of way so that it can actually be used inside of an algorithm potentially. So it could be something simple like going from a string variable to a numeric variable, basically if those strings happen to be categories of some sort, and moving into essentially categorical sort of encoding. Also there's this concept of turning things into like a bit vector, which is something you do to also handle the categorical sort of classification. Sometimes you'll also potentially take a something that is categorical in nature, so maybe you've got categories 1 through 4. You massage that to be essentially 4 different columns with a flag of true in the one that is appropriate for a given row. And there's reasons for all this, but the gist of it is that it's about changing the data in some way. So transformation, transform it, modify it to be something other than what it was before, with a purpose. It's not just something we do because it's fun. We do it because we need to get it into a certain certain type of shape. Deliverable 6 is going to be, we'll talk about it in a more detail later, but it's around essentially continuing work with the GAFA data set. And basically figuring out if you had $10,000 a day, how much could you buy of each, doing essentially an even split across all 4, so $2,500 per stock. So it's taking the price and the amount of money you have and how many shares can you get for that much money. That's the primary part of that. Then you're to take, for the R side of that equation, to take the data that's generated in the first part, which you do in Python, and do essentially a distribution plot to show where those things fall. Deliverable 7 moves into doing some analysis based upon what's the most profitable business model, dealing with a retailer that is trying to figure out why it is they have more sales on certain days based upon things like if it's a holiday, if it's a Monday holiday, and so on. That also ties into the concepts of doing performance analysis and figuring out what features need to be limited to. Your reading for this module centers on chapters 8, 10, and 12, data wrangling, another fancy word for data transformations. The idea is to take data, as I've said, change its shape, maybe combine it together with some other stuff based upon some column or some characteristics to essentially enrich that data. That's kind of the primary point. Data aggregation and grouping around summarization. So taking and doing aggregates, rolling things up, adding them up based upon a certain characteristic, potentially one or more attributes, and doing some sort of representation or discussion of those values as well. And then some advanced pandas functionality, chapter 12. It's a good thing to know. Pandas is a very useful and powerful tool. It also sets you up for later on if you move into some other data frame type technologies, such as Spark's data frames or their equivalent of or work-alike or something very close to pandas called koalas. Then in the R book, step by step, take a look at strings and factors, and then also cleansing and transforming. Again, data wrangling often has this concepts of cleansing as well. Not explicitly called out in that particular title of chapter 8, but definitely part of the whole process. When we talk about data transformation, it follows a very predictable pattern. We do this pretty much regardless of what type of project we're doing it on. It starts by obviously reading the file. So you start by reading into the data frame. You potentially join something together so that they're comparable. You oftentimes create some new columns, such as maybe an average. or maybe something like shares per day. Join things together using a merge command. Then you save that output typically to a new data frame. Then determine if the answer, if the question's been answered, or determine what question it is you're wanting to answer. But I would suggest that you're doing all those things starting from pretty much 2 on, maybe even 1, knowing what the question pretty much is. So you probably want to do a determination if you have the information that's necessary to answer it, more so than what question are you asking. And then solve the question by using the appropriate formulas given the data you have. And then, generally speaking, you report on that analysis in some fashion, potentially making some visuals, or maybe including raw numbers, depending upon who the audience is. And again, these are kind of common sort of things we do. There's also one in there that's probably been skipped over, which is 1.1 or so, which would be spend a whole lot of time both evaluating the data that you're looking in, and then also potentially cleansing considerably. Oftentimes data science projects spend 70-80% of their time in things like data cleansing, data curation operations. It's an unfortunate fact of how the world exists, so keep that in mind. Moving on to Python, a bit of a discussion around strings. I believe I've covered some of these in the past, but we'll go over them again just because it's handy to know. So you typically want to find something inside of one string, so it's essentially substring searching. That's where find works. It's very much like grep. You may want to know how long something is, and that's where len is. That works not only with strings, so keep that in mind. Splitting and joining is a way of taking either an array and turning it into a string by joining it together on a particular operator, or doing the opposite of that, of taking a string that has some things in it and then separating it back out. These are common operations that you do, such that the split and join operation have actually made their way into other languages, having originated here. Substring operations are pretty handy too, because they allow you to start inside of what's essentially like an array. You can think of it that way. It's not exactly, but you can say start at a certain location and go to a certain location, and you can have essentially kind of wildcards on each side of that. So you can say start at the 3rd character and go all the way to the end, or you can say go from the beginning till the 7th character, all those kind of operations. Very handy. Those things also apply oftentimes in other situations as well, so it's worth learning that kind of shortcut notation that allows you to go through and filter the results, or produce another string from one string, or even data frames based upon that characteristic of using that substring operation. So very handy to know, definitely worth spending some time with. One thing that when you're thinking about the 6th deliverable, you may want to start with the M5 deliverable. So what I'm showing you here is how to make a copy of a notebook, so you can basically create a clone of it, then change the name to something perhaps more appropriate so that you can then find it. And then you want to go through and start manipulating the materials that you have, making sure obviously things are correct. You don't want to mess anything up. That's why you made that copy. And then once you get to that place, you may want to do some more work, such as maybe merging it on a particular field like date, and then potentially doing some stuff like dividing the number of a certain amount of money by price per share, so that you can figure out how many shares you can get. So again, going through kind of the process here of making a copy as a starting point. Once you get that copy made, then you're going to probably want to move down to the next bit. We've got them merged together. We've got an average calculated. We're creating a slice based upon the various, or creating a function that allows us to do the slicing so we can merge them back together, merging them on date so that we're creating a combined data frame. And then you want to figure out, well, what's how many shares can I get? And it's how much you got by how much are they? And that gives you roughly dollars per share, or shares per dollar that you can buy. So that's the basic idea. So if it maybe hopefully not too much of a spoiler, but understand that what I'm showing you is kind of a bare minimum. I expect things a little bit better than what I'm showing you there. Moving over to R. and R string functions. Very similar sort of conversation, although it properly has something called grep, which is just like Python's find. Grep, if you're uninitiated, kind of came from the Unix world or Linux world, and it's just that for finding patterns inside of strings. Also has the ability to do paste with a separator. That's very much like a join. And then a gsub, which is kind of like a replace, and a string split, which is like the Python split. So kind of you can go both ways, so to speak. So you can merge things together and split them up based upon delimiters. There's also a substring function that's very kind of similar to that substring notation we have, but this is more like a traditional function call sort of thing. So that gives you a basic idea. Moving over to deliverable 6. Back in your consulting organization, you want to expand your knowledge and demonstrated capabilities of merging and combining data different ways. So you want to basically model up a portfolio based upon a consistent amount of investment each day and how many shares would be purchased over that. The basic idea, there's 2 submissions. One of them is in Python, one is in R. Your first submission in Python, you take the GAFA stock prices file, create some categories for your 4 stocks, so that you can identify the number of shares that can be purchased with the 10,000 each trading day, so $2,500 per share or per stock. This will rely on combining the 4 prices of the 4 stocks per day using advanced grouping functions in both R and Python, and also making sure you're joining on the date. Assuming a portfolio contains an equal number of shares and all 4 stocks will generate the number of shares purchased. Your output's going to be a plain source file that basically is going to tell you essentially how many shares are purchased per day. You turn in your source code and your output as well. Using R, you take you'll take the stock prices using your output file from the first submission and generate a distribution plot of the stock prices. Your output will include both your source, basically what you submit is source code and plain text, and that likely ends with extension .r, just like the Python either probably ends in .py or I, whatever the notebook equivalent is from a Jupyter notebook. The rubric, as always, shoot for that mastery column. Don't mess around with the lower ones. To do that, make sure that you include every one of those little sub items. They may not seem as straightforward, but you do want to make sure that most things up to here are kind of the bare minimum across each one. And then it's going to be things like including significant error checking or handling or appropriate analysis to determine if errors have been encountered. Also make sure you do some grouping so you can do some analysis. The logic determined that the file was read incorrectly as well. And then in R, use basically make sure that it loads it in, append, and so on. More error handling and logic, and determine if the data was read correctly, and then generate a simple distribution point using significantly more advanced options to customize the graph. So don't just use the defaults, make it pretty. And that's pretty much deliverable 6. Moving over to deliverable 7. This is essentially your head, your keystone, or your overall capstone project. The idea here is that you have demonstrated all of the things that we've done in this course. So you have set up an analytics environment, you've applied data structures and objects and classes. By utilizing the built-in learning resources, you'll be utilizing scripts and programming languages to read and write data. Used in data science, utilizing core programming fundamentals to achieve desired analytic outcomes. And you'll have employed some advanced data structures along the way, such as data frames and dictionaries and such. And you'll use some preliminary advanced programming concepts. So advanced programming fundamentals kind of seems like an oxymoron, but it is basically you're getting near the end of the introduction is probably the best way to put it. Moving into the scenario, you've got some sales data out here that comes from a clothing store or retailer, and you have a number of attributes associated with each one of the sales. Your idea is to come up with what is the things that are making the biggest impact on the sales per day, and you do so by using a decision tree, leveraging data coming in through probably a data frame or associative array. And then you want to do the splitting of your tests, so over and under the median sales, so which is above and which is below. And then you want to figure out which one of the attributes contribute to it either being high or low. So the instructions, basically drilling into that a bit more, you'll use the Rossmann dataset, and then you will use either Python or R. So in this case you get to pick, and that's a key difference on this project. So either. It's not an and for this project. And you want to read in the associative data set, associated data sets. Then you're going to load the data either into a data frame or an associative array, something that is your preference. I would go data frame. And then you're going to apply some Python or R libraries that are either CART or SK scikit-learn. And CART is also available in Python too, so if you want to use CART, you don't have to go with R, just so you know. And then perform the analysis and output the file containing only the limited feature set, so you're going to figure out what features make more sense, and those are the ones you're going to focus on. Notice you will have only a single submission in your source code in basically the text, plain text format, so, and also any output that is generated. And you'll be implemented in your preference of either Python or R. So I would recommend for this case making sure that you do include pretty good comments, right, in your code. That's one thing that's going to contribute to this. Include significantly more error checking to ensure data was read successfully. That's kind of always there, but part of what we're going to look for is the code exemplary. So did you include error handling? Did you include comments that explain what you're doing at a very high level, and so on, so that somebody can pick it up and understand what you're doing? You may want to think about using something like a notebook, because that's one way of kind of incorporating those two things together really well. Convert the data into either a data array structure, array of datas structure, or data frame. Then make sure you're doing, again, error checking and determination that it was successfully converted. And then utilize an analytics tool such as CART to determine factors that drive sales. Include significantly more analysis such as regression and machine learning to determine what factors drive sales. So in addition to the decision tree, probably want to do a little bit of regression and machine learning to determine essentially what's the factor analysis here, which is what you're doing, of what factors have the biggest impact. Then utilize R or Python to generate meaningful output and graphs to present the results of the analysis. Utilize significantly more advanced options in the output beyond the default settings, so make them pretty, and make sure it's not just the bare bones and the minimum. And with that, I've reached the end of what I have to say. As always, if you have any questions about this material, do let me know. This is potentially a bit challenging, especially as you move into Deliverable 7. It's a little bit vague in places, and certainly if you have questions, do let me know. That's what I'm here for. As always, stay safe, and I will be speaking with you on Wednesday.